Hey everybody, thanks for joining me today. We're going to get into number properties, and we're going to go a little bit deeper into it by not just naming what property is being used, but actually filling in the blanks and taking a look at what's missing in order to make a property work. So not as many problems as what I usually do, but there are multiple steps. All right. So we look first at 3 times 5, and we want it to equal something times something. Now, if we want to demonstrate a property, 3 times 5 is 15, and I would say 5 times 3 is also 15. That seems like it makes pretty good sense. That would be the property that we use when the two numbers change order. They're changing from one place to another. They're switching sides. Compared to each other, not like in the equation or anything. But anyway, that to me would be an example of the commutative property. And in this case, it is the commutative property of multiplication. So this would be where the numbers change order. Once again, a shout out to the teacher who I read the material of just a few days ago. Commutative starts with CO. Change order is abbreviated CO. It all works. Whatever cheesy stuff works for you, that seems to be a really good way to go. I use those cheesy things all the time, so let's just go with it. All right, example number 2. You've got the number 15. You want to multiply it by something, and you want to turn it into negative 15. Seems to me the only way we'd be able to do that is if we multiply it by negative 1. There's a property for that. You know, a property when you multiply something by negative 1. Maybe like the multiplication property of negative 1. Oh boy, this is going to be a long day. All right, never mind. All right, let's go to example number 3 here. You've got 1, 2, and 3. Currently, the 1 and the 2 are being grouped together. If we were to group the 2 and the 3 together instead and leave the 1 on the outside, would you get the same answer? Turns out you would. It doesn't matter how the numbers are grouping together. It doesn't matter who they are associating with. Hint, hint. You're going to get the same result. So that's what I would fill in for that. I would basically just change the way the numbers are grouped to prove that the associative property still holds true. All right, example number 4, 5 times 0 equals, I'm not going to lie, even as a teacher, sometimes it's tempting to write 5, but it is not true. It is 0, because if you multiply by 0, you're going to get 0. That is the 0 property of multiplication. All right, last one in this section. What if you have a 5 and you want to keep it as a 5? You want to make sure the identity of the number stays the same. In this case, we are using addition. So if you want to add something to 5 and you want it to stay 5, the number you have to add is 0. Now, since the number 5 stayed 5, the identity of the number stayed the same. That means we are dealing with the identity property. In this case, it is addition. If we were using multiplication, we would have to multiply by the number 1. All right, answer these without a calculator. So 296 plus 342 plus 4 without a calculator. It is not meant to trick you. It is meant to force you in to using the commutative property. That was the goal, because if we rearrange the order, we get something much easier. 296 plus 4 just gives you 300, plus 342 gives you 642. Let me write it a little bit bigger there. Perfect. So, changing the order is the key to making these problems a little bit more pleasant. It is also the reason why some people can do crazy math in their heads and other people just sort of sit around and stare at them and wonder how it happens. All right, example number 7, 5 times 17 times 20. looks to me like if I rearranged this and put the 5 times the 20, I would get 100. So if you did 5 times 20, that is now 100. And since it's now 100, you could multiply it by 17, and 100 times 17, wait for it, 1700. So once again, we're talking about a situation where rearranging the numbers makes your life better. Example number 8, I tried to make scary looking, but I think you can probably see through it. 1/7 of 7 is just 1. 1/7 is the reciprocal of 7 over 1, so when you multiply the two together, you just get 1, which basically means if you change the way you look at this problem and deal with the 1/7 and the 7 first, you find out you're going to keep a final answer of 5,271. So it's important to kind of look at what you're doing before you do it and think to yourself, is there a way I can reorder, or is there a way I can regroup that will make this problem easier so that I can do it without a calculator? I don't know what 1/7 of 5,271 is. Maybe you do. But if we change the way we look at it, we can get it right. All right, thanks for joining me. I appreciate it, and I wish you good luck the rest of the way.